Hello guys, welcome to this introductory video on GNU Radio Companion. In this video, I will introduce you the software GNU Radio Companion, and also I will do a simple signal processing operation using GNU Radio Companion to give you idea about the software. So this is a free software, and this software GNU Radio Companion can be used to perform signal processing functions, and also it can be used for radio applications. And this software is widely used along with SDRs or software defined radios. You can use this software to design your radio application or signal processing function. You can graphically build your signal processing function in this software, and then when you run the program, your Flowgraph, it will be converted into Python program. But you don't need to know the Python programming language, but it will be helpful if you have some understanding about the Python programming language. First, let me create a new Flowgraph. If you can see the button in here, you just click in this button, then it will create a new Flowgraph. Then you can, before working on with the Flowgraph, you can save it. Just file and click on save and give it a name, and then click save. First, I will give you an understanding about the layout of the software. This is your workspace. This is where you build your Flowgraph, and you can see there are a number of buttons above that are useful when working with the software. And on your right, you can see a number of items. These are the blocks that you will be using when you're building the Flowgraph. If you just click one of these blocks that menus, then you will find various types of blocks. I will introduce you some of these blocks later. And below in here, you can see the variables that you are using in this Flowgraph, and in here you can see the command line interface. And before building the Flowgraph, you can see there are two blocks in here. First one is options. If you can double click on here, then you will get the basic parameters of this Flowgraph. And as you can see, you can give an ID and title and various basic information. And one thing I need to mention that for this generate options, let's keep Qt GUI. Then when I progress through the Flowgraph, you will see why I have chosen this one. Okay, and click OK. And this variable block is very useful. If you can double click, this is the sampling rate for your entire Flowgraph. It will be mentioned as samp_rate by default, and this is the default sample rate. You can change it if you need. I will mention as 48,000. Okay, then click OK. I will start the Flowgraph by introducing a new block. When you need to use these blocks, there are two ways that you can get the blocks. One is by browsing through these menus. You can choose the block you need, or else if you click in here, the magnifying glass button, you will get a search box. You can type the name of the block. I need a signal source. Let me type source. In here you can find in this one the signal source. To get the signal source into your workspace, you just click in here and then drag and drop. Okay, you can move this block here and there by clicking on the block, and then by using the mouse you can move it to wherever you want. Okay, and then If you need to change the parameters, just double click. And here one important thing that I should explain is the output data type is mentioned as complex. You can use any data type that you need. If you can observe, the color of this area is blue, this interface is blue, that means blue means complex. If you change it to float, say float, then click OK, then the color change to orange. So orange color is for float. Okay, let's double click. Now this is a signal source. According to these parameters, it will generate a cosine signal. So I'm going to change this to sine. And then the frequency, I'm going to the default frequency is 1000 hertz. I will keep the default value. And amplitude you can change if you need. I will change it to 2 and then click OK. Okay. Then one important block that I need to introduce is called throttle. Okay, click and drag it in here, and this throttle block is very useful because if you have not connected any real hardware into your flow graph, then you must use this throttle block. This is used to limit the consumption of CPU. For that, if you do not use this block, your flow graph might con- uh, consume all the processing power of your CPU, and it will saturate the CPU. To avoid that, you should use this throttle block. But if your program is connected to any real hardware, then you can avoid this throttle block. Uh, I'm going to use this because I am not connected to any hardware now. You can double click and then change the data type to float. Click OK. Now the colors change to orange. The next thing I need to explain is you need to connect these two blocks. How you connect? You first click on one of these interfaces and then next click on the other interface. Then these two blocks connected, and use, as you can see, the color of the title changed to from red to black. Okay, then I'm going to introduce another signal source. I can get that block from here also, but I prefer to copy this source and reuse it. In order to copy, you just click in here, press Ctrl C from your keyboard, and then click in here and Ctrl V. You can click and drag the new block, and I'm going to change the details in here. I will make it a cosine signal with same frequency. Oh, maybe I can change the frequency to 2000 hertz, and I will change the amplitude to 1. Okay, click OK. Then I need to add these two signal sources. I'm going to introduce the add block in here. Just click in here, click on the search button, type add, and click and drag that block. As you can see, it is blue color, that means it is in complex data type. Just double click and change the data type to float. Click OK. I will connect these two from here to here, and also from here to here. Now I'm adding these two signals together. I need to see the outcome. For that, I'm going to use another new block. It is called QT time sync. Click and drag. This is called QT time sync. This block shows the waveform in time domain. Just double click and change the data type to float. you should keep the same data type across your flow graph. As you can see, there are some parameters in here. This is the y-axis label, and then this number of points is the number of samples in the x-axis. I will keep the default value, and if you go below, you can see some other parameters. This is sample underscore rate is the sample rate. We have set the sample rate to 40,000. It will be reused in here, but if you need to add the custom sample rate, you can erase this and enter any value that you need. uh, then grid, you can turn on the grid, or I will not use the grid at this moment. Auto scaling, I will turn on auto scale, yes, and then click OK. Now I will connect these two. Okay, now I'm going to run this flow graph. In order to run this flow graph, just go above. You can see a triangle, a play button in here. You just click on that button, then it will run. If you maximize this window, you can see your signal in here. This is the signal after adding the sine and cosine waveforms together. I will close this for now. Now I have introduced you the Q2GUI time sync block. Next, I need to see how this addition performs in the frequency domain. For that, I need to click in here and change the name to Q2GUI frequency sync. You just click and drag the block in here, and then double click, change the data type to float. In here, I will keep all the other parameters, the default parameters, and click OK. Now this block will be used to see the waveform in frequency domain. For that, you just click in here, and then in here, these two blocks will be connected. That means the output of this add block will be able to we will be able to see the output in frequency domain. Just play, and then you can see above, you can see the waveform in time domain, and below you can see the waveform in frequency domain. Let me close this window. Now I'm going to introduce some noise to this waveform. I will delete this second signal source block. Just click in there and press delete button on your keyboard. Then click noise, click and type noise. I will drag this noise source in here. Okay, I will double click and change the data type to float. You can change the noise type. I will keep this Gaussian noise and click OK. And you can change the amplitude of the noise. I will keep the default value and click OK. Then I will connect these two together. If I run this flow graph, now you can see how noise has impacted the waveform. This is the waveform in time domain, and also this is the waveform in frequency domain. As you can clearly see, the noise spectrum has impacted the spectrum of the waveform. And then close this. If you need to see the time domain waveforms of these two, this signal source and the noise source separately, just double click in here, and if you go below, there's something called number of inputs. That means at the moment it takes only one input. I will change this to 3 to have 2 more inputs. Then click OK. Then I will add these two. I will click in here and in here to add the signal source. Then I will add the noise source also. Then I will run this flow graph. Okay, Now you can see all three signals in the same window. I will, as you can see, those three signals are portrayed in three different colors. If you click in one of these, it will turn off. And then if you need to turn off the noise also, click in here. Then you will have only the signal source in this window. And let me close this. Okay, then I will change the time sync to back to its original form. Let me change this to 1, and then I like to have see these two in two separate time domain windows. For that, I need to introduce two more Q2J time sync blocks. Just click Control C and then Control V. I will keep it in here, and I need another one. Press Control V, and I will keep it in here. Okay. Now I will connect these two together, and also connect these two together. Okay, I will change the settings. So you can see the settings. Okay now. Okay, settings are okay. I will run this flow graph. Now you can see the waveforms are in separate windows. The waveform in the first waveform is the noise source. The second one is the signal source, and the third one is the combined signal. You can see how the noise has impacted the waveform. And if you go below, you can see the frequency domain representation of the waveform. Let me close this. Okay, another thing that I need to explain you is you can change these parameters by using a slider. For that, you should get Qt range. Just click in here and drag it somewhere in here. I will keep it in here. For now, let me double click. I'm going to change the frequency of the signal source by using this. And for this, change this ID to something like FRAQ. Then let me have start frequency as 1000 Hertz, and a default value, let me keep it in 1000 Hertz. And then let me change the stop frequency as 2000 and the step size 100 Hertz. Let me press OK. Then what you need to do, go to the signal source, double click in here. Instead of the frequency value, you specify the frequency as FREQ. Okay, press OK. Now if you run this flow graph, you will see a slider in above. You can click and drag this slider to change the frequency and observe the change in frequency in the waveform. Okay, if you see the change of the frequency in this waveform, when you click and drag on the slider, it will change the frequency of the waveform in real time. So this is a very useful feature to analyze the performance of the signals. Let me close this window. Okay, another important feature that I need to introduce is that you can save these parameters, the output of this add block. You can save it in a file. How to do it? For that, we need a special block. This is called file sync. Click and drag, and then I will double click, change the data type to float. Okay, in here you need to give a location to your file. just click in here. I will save this file in a separate folder. Just click in here, create a new folder, your folder name, press enter, and then I give a name to the file. I will tell test file, and then click save. Now you can see the location and the name of the file, and then in here you can mention overwrite or append. If you select overwrite, when you run the program once and then run the program second time, the data in the first time will be overwritten by the data in the second time. But if you select append, it will keep appending the data. Your data will not be lost. And then click OK, and then you need to connect this file sync to AdBlock. Now what happened in here, when I run this flow graph, the output of this AdBlock will be saved in this file sync. I will run this. Meantime, you can observe the performance of the waveforms, and also in real time the data will be saved. Let me close this window. Let me go to this location to see if the file is in there. Just Control C, cancel, and then in here paste the folder, click enter. Then you can see the file, the test file is saved in here, and you can see the size of the file, the data I have saved in this file. I hope that you could gather some useful information about this software from this video, and if you enjoyed this video, please give it a like, and also please don't forget to subscribe my channel. You will be able to see more informative useful videos in future. And guys, thank you very much for watching, and bye bye.